Okay, it works. So, OpenStack. Year ago, it was, come on, busy word, right? Busy word. So let's take about one short note about me. I'm doing ARM for 13 years now. AArch64, I will say in a moment what exactly it is. For 5 years, it was interesting journey. I had own company working on OpenMB, Yocto, etc. There will be some sessions about Yocto after my talk. I worked for Canonical, and at that time I was at Linaro, Linaro is a project to make Linux on ARM great again, let's say. Left Canonical, joined Red Hat, worked on getting AArch64 support in RHEL and Fedora. Now I'm again at Linaro, this time as Red Hat assignee. I was involved in far more distributions that I remember, so I listed just 5 of them which I played with recently. So, I will tell a bit what AArch64 is. Julian told something about it, some people probably know, but for those who don't know, a few words or what OpenStack is, how situation of OpenStack support in distros we use at Linaro looks like, think about deploying, some stuff about how we did so-called Linaro Developer Cloud, which is using OpenStack. Oh, my timer is not running. So, it started. Awesome. So, what AArch64 is? In short, it's 64-bit ARM. At the beginning, we were calling it just ARM v8, but sometime later, ARM made us a surprise, and they released 32-bit only ARM v8 CPU. So, we stopped using ARM v8 as a synonym for 64-bit ARM. And basically, it's a family of CPUs where you have 64-bit CPU core and can have 32-bit one. Most of current designs of 64-bit ARM CPUs have 32-bit support still, but there are also CPUs which don't have because it takes time. And basically, who needs that, right? If you are making 64-bit CPU, then make it pure 64-bit and forget about the past. It will make good things for you. And there is one thing which I suppose I noticed so far many people don't recognize. ARM is no longer this small devices, Raspberry Pi type developer, so-called developer boards, because I will not call this phones, tablets, Chromebooks. Those are limited ARM devices. I will not tell anything about them in this talk. What I am doing at work is ARM64 servers. Things like 8 cores, 24 cores, 48 cores, or more cores, 1-socket CPU systems, 2-socket CPU systems, tens or hundreds of gigabit Ethernet on board, huge amount of storage, huge amount of memory, that kind of systems. Like, for example, 48, you have a main board, 2 CPUs, 48 CPU cores in each, 1 terabyte memory per CPU, and a bunch of SATA ports for storage and something about 160 gigabit Ethernet on connectors. So it's not the small ARM people usually think about, right? The thing is, which is nice in AArch64 is that virtualization support is mandatory. Okay, it requires you to make it sane, so no Raspberry Pi, please. And it will just work out of the box. And Support for this is in kernel for quite a long time. It was 3.9 or 3.11. KVM works, Zen works, this jailhouse which Julian was talking about works. So why not use it, right? Especially when you build software for new architecture, you have failures because no one knows how to deal with this architecture. You have to fix it. Then developers say, I will not accept your patch because I need to check it and I don't have hardware. So virtualization came because some people have hardware and they can provide access to this hardware to external people, but you don't give bare metal to someone you don't know. You want to give them VM. And to give them VM in some sane way, it's good to have some layer on top which will take care of access, networking, taking care of everything, and this is where OpenStack comes in. And OpenStack is basically a set of frameworks. Mostly Python is used to write anything. We have compute nodes, we have networking nodes, storage, we can provision systems from using PXE, so we just provision bare metal. We can provision virtual machines. We can make virtual networks between virtual machines. We can migrate virtual machine from box to the box. Basically, when it comes to OpenStack on ARM64, you have more or less the same as you have on x86-64, except nested virtualization. So, the components are like, for compute, we have Nova, which is component which takes care of running virtual machines, stopping them, basically take care of just virtual machines, not its storage, not network, because for those are different components. We are using Ceph as a storage for all our images, so we can just move one VM from server to server, switch the one we don't use for some reason, like hardware update or something, and then just works. So things like, but if you want to run OpenStack on your system, you need to install it firmware, right? You can, of course, do like people used to in ancient time, you can build everything. Or you can just grab one of normally supported systems and install your OpenStack stuff from somewhere. At Linaro, we are taking care of we basically support two distributions, Debian and CentOS, because both are community-based. Sure, behind CentOS is Red Hat, but it's done to make sure that CentOS will exist and will not vanish somewhere. So Red Hat employs several people from CentOS team and provide them storage, hardware, etc., and do what you need, what you want to do. We will not tell you that, oh, you need to make sure that this thing is done, right? This is left for CentOS team. So, in Debian, we used Jessie, and for Jessie there were several versions of OpenStack packages, or rather, packages for several versions of OpenStack, and this was done by Debian OpenStack team. It was nice collaboration when we asked for, can you help us build packages for ARM64? The question was, okay, give us build machine, and we will take care of it. We gave them, they built packages, we used them. For CentOS, we got packages built by guys from RDO project. They care about OpenStack for several versions now, by providing packages for CentOS. And when I asked RDO guys, what exactly RDO means, they pointed me to FAQ, which is RPM distribution of OpenStack, ridiculously dedicated OpenStackers, etc., etc. There were few more versions which I prefer not to repeat, but they were funny, at least. So, we have hardware, we have packages, we need to install. We need to get something working, right? There are several ways of deploying OpenStack. We tested few of them already. One, which is the favorite way for OpenStack upstream, is DevStack. It's very ugly shell script, in my opinion, which does the work. It fetches source code of all components, builds it for you, asks for some passwords in meantime, and it does more or less, at the end you have working something. You can do full stack implementation, like I want to run the whole OpenStack on one system. You can populate just several components. Depends on how many switches you will give to DevStack script. The other way, which we tested, was PackStack, which is also shell script, done by RDO guys. It also installs required components, but it is using packages from RDO guys. And at the end, it at least leaves you a file with information, what it installed, what passwords are. You don't have to remember the things. And you can just reuse this file for next installation. And of course, the next step is just to automate the things, because we are living in DevOps world, right? Everyone wants to optimize things and run a script and go for coffee, or another coffee, or watch TV series, or play Diablo. So, there are, like I mentioned, that we can do several types of installation. Those are two examples of testing configuration. Because first one, the OpenStack in one host, is also called full stack, which means I am a developer, I want to check how things work. I am installing every component on my machine, or basically on one machine, and get it running. You run DevStack, you install Keystone is for authorization, Nova for virtual machines. Ironic can be skipped in this situation. Horizon is dashboard, Neutron is network, and Glance provides images. There should be also Cinder there, but never mind. And you can run it on one machine. The situation on AArch64 which complicates this thing is that on x86, you normally does it in virtual machine. So then you run the full stack in virtual machine, in which you run OpenStack you use OpenStack to run another set of virtual machines. On ARM64, we don't have nested virtualization in currently existing CPUs. So this way is not the way we go. The other way is separate nodes. So we have control node, where there is networking, dashboard, images, and authorization. Then compute node, which only has Nova, which will run VMs on bare metal. And we have storage nodes, usually using Ceph. At Linaro, we joined those functions, so our compute nodes are also storage nodes. Works perfectly. And then if you have few storage nodes, then you can do live migration for free, because all VMs will use images stored in Ceph. Ceph you have on several machines, and then if you need to shut down one of Ceph storage boxes, it will use data from the other ones. So, going by this, we went and decided to make developer cloud, so-called version 1. The idea was, we, as Linaro, have some hardware from our member companies, and we have to do something with it, while there are a huge amount of people who don't have access to this hardware, and they need to port their software to the new architecture. First version of our cloud was based on OpenStack Liberty. It was quite a long time ago. It was done by hand on Debian Jessie operating system. At the beginning, we used Debian packages. Then a new version of OpenStack got released, new packages, and our administrators decided to build Liberty in a set of virtual envs. Virtual env is a Python way of doing, let's say, change root for just Python. Right? You have Python, you have all Python packages in one place, and you just use it instead of using the system Python. So we did a set of virtual env tarballs per each component. It was working, but there was no API access for external people, no horizon, so no dashboard. You basically got IP of virtual machine, login, password, go, free to use, tell us when you don't need it. Networking was done in a very basic way, just to get everything working. Liberty version of OpenStack didn't provide any way to use any bootloader, which we used already in virtual machines. So we were using direct kernel plus initd way of booting, which is kind of pain when you need for some reason to use different version of kernel, because then you have to mail to admin, I would like to use this kernel within this initd, can you please change it for me? And everything was managed by our administrators. So the queue of people who wanted to get access became longer and longer, because at one moment there was just one administrator for all those requests. But there were several people, there were over 200 projects, companies, which used this version of cloud for testing or porting their software. In the meantime, we skipped the Mitaka version completely, and we integrated all our fixes into upstream, and we decided to base on snapshot of Newton release. We still were using Debian Jessie, because nothing changed in Debian stable, right? We built some external packages for it, like the newest libvirt package or a few other things. And we still were using our way of deploying, which was virtual env tarballs, and then we created packages which contained same files to make easier to get it installed. Playbooks for Ansible were created, so it was deploying the whole cloud was just a matter of few lines of code. Everything is in documentation linked. But the good thing was that it was based on Newton, so we got things like UEFI support. Your VM was booting to normal bootloader, which loaded the normal firmware, which loaded GRUB from your VM or whatever EFI compliant bootloader you were using. So users of VMs could change their kernels without going to admins. We gave people access to API and dashboard, because it was like, okay, here you have login and password to dashboard. You have 2 vCPUs, 8 gigs of memory and 40 gig of storage. We don't care what you do with it, as long as it is not something illegal, right? We had networking based on Open vSwitch, so things like virtual network between several virtual machines were possible. So you got some resources. You could make own VMs connect them into one virtual network, and use just one public IP for the whole your whole network. And the biggest, one of the other big changes was shared storage with Ceph. We finally had working live migration, because previously, for some reason, our administrator needed to get some machine from the rack because something was failing. He had to contact, or he had to check which users have VM on this machine, contact them, inform that in 2 days I will switch off your machine. You will have like half-hour break in services, and then take machine, do what he needed, put it back, run all VMs again. This time we have live migration. You just you just select, take this machine down, wait until all VMs migrate to other devices, and you're done. Just like on x86, right? So, and this is how our reference architecture, or rather, reference architecture of Linaro Cloud looks like. We have 2 networks. One network is for management, and this one has access to the internet. And second one is just private between all nodes. We have API controller. It runs authorization, it runs images, it runs APIs, network, dashboard, and monitoring of Ceph storage. Then we have data controller with database and also second Ceph monitor, just in case. Basically, we run Ceph monitor on every controller. Another thing is network controller, and then we have compute nodes which run Nova Compute to be able to deploy VMs there. Cinder Volume is just a way to provide access to images for VMs, and Ceph OSD is storage stuff. Some nodes are connected are not accessible from outside. Some are, so it works for us. That's good. And from what I was told, we finally got rid of all old instances of our cloud. So now Linaro runs at least 2 setups of cloud, one in US, one in Europe. And we are now working on getting one in China for their market, because getting to internet from China can be quite difficult. So, and then we have some plans. Everyone has plans, right? Again, we decided to skip one release because OpenStack Okata was released last week. We decided to completely skip it because we had other plans for it. We are moving to Debian Stretch because officially it's still Debian testing, but it's already frozen, so we don't expect any big changes. It gives us huge amount of updates compared to Jessie, even with backports. And we also plan to be trendy, etc., and we will move to containers. Because now our approach with those virtual envs packages, it took us a long time to get it working, and we had to write documentation for it. We had to provide support for it, etc. It takes time when we are not the support company, but we are development company or development project. So we want to work on development and not have to care much about support. So we decided to go for containers and to not invent the wheel again, like many people do. We are using one of OpenStack project named Cola for building Docker container images. It was tough, right? Because it again landed on my desk as I work as build engineer for all those years. And I looked at the project, noticed that it was, as usual, x86 64 only. So brought some patches. They still wait in the queue, but gets reviewed, fixes. Hope it will end in next few weeks to be merged. And for now, I built something like 1,500 container images for OpenStack using CentOS as base, Debian Stretch as base, or Ubuntu 16.04. But we will not support Ubuntu 16.04, but as this is the quite popular target in OpenStack community, we use that to check does building on ARM64 works as it's supposed to be. And to make it, there was a funny moment when I was using code for let's make it work on ARM64 on Power 8. Power 8 is interesting architecture, but this is not for talk. Next set of our tests plans, testing, automated testing. We have contacts with Power guys from IBM who are working on the same stuff but for Power architecture. They have already experience with getting external CI for OpenStack running, automatic test, this kind of stuff. So we will work on their knowledge and we will set up our CI on our development cloud machines to make sure that whatever got into OpenStack, it will be tested not only on x86, but also on ARM64 and Power 64 Little Endian. This will be a huge change, in my opinion. So I added this just for OOO. How many people know what OOO means? One. Awesome. Or rather, sorry, cool. And OOO is a very popular buzzword in OpenStack community. It's mostly used during development and for some people also on deployment. OOO means OpenStack on OpenStack. So you are running one virtual machine in which you are running the whole OpenStack, and in this one you are running VMs. So you have nested VMs, and as it was told earlier, there is no nested virtualization on ARM64, which gives us a small problem because everyone around is asking us, do you support OOO? We don't. The thing is that, sure, it is available in the latest public version of ARM v8 specification, but there are no CPUs with it. It was tested only on software models, which are slow. And during last week, at the session, What's New in QEMU, guys from QEMU told that they have nested virtualization in QEMU now, and they went 4 levels deep, and it was enough to get it into the crawling speed. So one solution for this OpenStack on OpenStack is we can run OpenStack on one machine and then provision bare metal instead of using a virtual machine. It's a thing which works, but I don't know how much it was tested. We have it on our to-do. The other way is to use QEMU in emulation mode, but this is good only for development, I think, because it will be slow. And we go to the point where questions. The person behind who knows what OOO is.
Thank you much for your talk. I've got several questions. First of all, I was very disappointed that you missed Cinder component on one of the first slides. It's not honest to the people to say that CF is for object and block storage, because Cinder uses it to provide storage for OpenStack.
Okay, I will,
my personal note.
I will add one thing. I am mostly build engineer. You know, it's like I know names for several components. I used maybe 3 of them or 4. And for me, Ceph is kind of magic box which keeps my images, right? And I know that I have to put them on at least I need at least 3 storage nodes, and not 4, but 5, right? This kind of stuff. So yeah, I am simplifying things.
Thank you, fair enough. And one more question. You show us a reference architecture. Is it supposed only for developers? Because I think it's not production ready without storage network with
you mean
OSDs.
This one?
No, reference architecture.
Oh, reference. Okay.
Yeah, this one. Is it for developers only?
We have this in production.
Oh.
You know,
it's better said.
When we designed the first version of reference architecture, we had something like 6 servers. So with limited resources, we went for this model. It worked. And there are plans to make things different, because now we get more and more hardware because member companies see that this model works. So we hope to make some changes.
Okay, thank you. And the last very quick question. When will you going to implement CI for upstream testing with ARM architecture? Because it's a very awesome feature, and I believe people would like it and will use it.
Our plans to get third-party CI is as soon as possible, because we also need it for testing our stuff. Because it's hard to get, sure, OpenStack community is a set of people which we love because they are really helpful. But sometimes it's hard to get, oh, please take care of this patch. It will do nothing for you, right? No one from x86, 64 will use it, but it will make life easier for us, right? So then convince people that it doesn't break anything, right? With CI running on different architectures, when this patch works properly, it's easier to convince people to accept patch. So it's also in our business to make it work as soon as possible. You're welcome.
I have a question. How secure it is? Are you going to use ARM Trust Zone in the future?
No. From what I know now, no plans to use ARM Trust Zone.
Okay.
Because, there is one thing with ARM Trust Zone. For those who don't know, ARM Trust Zone is a part of ARM CPUs which is supposed to work on things like DRM, secure payments, this kind of things. But the side effect is that Trust Zone has access to the whole machine, to all resources. The so-called unsecure part of CPU isn't even aware that Trust Zone's parts do something. On insecure world, you can have VMs running, you can have VMs in VMs running, you have separation of memory between those VMs, etc. And then you run Trust Zone component, it can do anything to them, right?
I have 2 questions. First one, have you tried using another network solution, for example, OpenContrail?
To use what? Sorry.
network solution, software-defined network. On this slide, you use OS, OpenOS switch solution for networking. Have you tried to use another solution?
No, so far we just went like described and only KVM things for it.
Okay, thank you. And one more. As I understand, you have already had CI for your solution.
And not yet.
Not yet.
When it
Are
comes
you
to
going
CI,
to run-
we are working on getting
Are
it
you going
done.
to run OpenStack Tempest, for example, and Rally on
No,
this?
we were running Tempest, RevStack, this kind of test things, but it was done manually, usually. So it's not yet what I will not call it any CI, right? For me, CI is like we do build when something got changed, we test it, this kind of stuff. Basically, as third-party CI, we want to replicate what OpenStack community does on x86-64 for testing.
Okay. Performance testing, maybe.
With performance, it can be quite complicated because some of machines we have available are not on market yet, are using or may use CPUs which are not announced yet, this kind of things. So there are machines like when, for example, NDA blocks me from using them because I am not a Linaro employee, for example.
Thank you.
One more question for me
Go.
again. You said that you are going to use Cola to bring these containers. Why do not use OpenStack Ansible, which already works with containers, which provides LXC containers?
You have to build containers,
Yes.
right? And one of our developers noticed Colab project, discussed with guys from this, and we decided, okay, someone took some time, wrote recipes for over 200 containers, so we decided to just reuse it.
But you can reuse it with OpenStack Ansible too. It's
Probably, but it's like there is a huge amount of projects around OpenStack.
yes.
So we just went for this one.
Okay, thank you.
You're welcome.
Guys, we still have some time to ask your questions. And compared to other threads which are running like
If someone has a question about AArch64 servers, for example, I may be possible to answer.
I really want to know your personal opinion. What is the time frame when like huge vendors of platforms like, I don't know, Amazon and stuff like that going to provide ARM servers for what is the time frame for that?
That's a good question. When cloud providers will provide AArch64 VMs? No idea. Seriously. Currently, there are one or two smaller so-called cloud providers who provide AArch64 images. I just don't provide the names. But Amazon, Google, Microsoft will. On a week ago, on Wednesday, Microsoft shown Microsoft Windows for Azure running on not named Qualcomm AArch64 server, which had huge amount of cores. It will not be, from what I was told, it will not be told. It was an announcement that it will be only for Azure. So we can, don't remember when, they told that it will not be immediately, probably at least half year or something, but there could be AArch64 VMs on Azure.
If we are speaking about AArch64 for Azure and some announcement we cannot say loudly, maybe you will say something about FPGA architecture? Or you have a lot of motherboards in one case? You know the topic or not?
Ah, I think you know which ones.
Of course, we cannot say about this, so it's only a question.
Yeah.
To guy from Red Hat.
No. Yeah. As I work for Red Hat, I have huge amount of NDAs signed for several things, so it can sometimes complicate the answering. But I think that the stuff you are mentioning it is the one which was presented on Linaro Connect last week. It's a machine which has 24 Cortex A53 cores, so quite slow cores, but 24 cores, and it was done in a way that carrier board has 8 slots which look like physically like PCI Express 616, and each slot takes a card with one of those 24-core CPU. What will be a target for it, I don't know, but it was quite interesting device. There.
One more question. Maybe I skip this information. Can I buy 10, for example, Raspberry Pi 3 and to create my personal cloud at my home?
When it comes to Raspberry Pi, you can buy 10, sure. You can even buy 100. Feel free. You will just waste your money, but it's not my money, so I don't care. You cannot. The problem with Raspberry Pi is that you have everything blocked by GPU. ARM cores there are just by mistake, probably. And everything is controlled by GPU. So even if you have, in Raspberry Pi 2 and Raspberry Pi 3, you have ARM CPUs which are capable of doing virtualization. But to make virtualization, you also need, I had it on a slide, you also need interrupt controller version 2 or newer. Raspberry Pi doesn't have any usable interrupt controller. The thing which handles interrupts inside blocks you from doing any virtualization at all. So, and trust me, 1 gigabyte of memory. When it comes to ARM64 area, I split it into 2 parts. ARM servers, usually $600 or more per box, and toys. Toys mean developer boards, everything which has less than 16 gigabytes of memory, so also Chromebooks, right? Because you cannot use them for things like OpenStack. And I remember on one mailing list, I think it was Debian ARM, someone wrote that they got virtualization running on Raspberry Pi. But it was done in a way that there was a huge patch to kernel which added emulation of proper interrupt controller. On boot, you had to tell kernel which CPU cores it shouldn't even bother to get running. And then when kernel booted on 2 cores, for example, you had to run modified QEMU, which will run VM on those 2 not used cores using virtualized, using emulated interrupt controller, just to make it think that, oh, I was capable of running virtual machine on Raspberry Pi. When you go to the store, you buy any all-winner-based CPU, and you will run VM without doing such ugly tricks.
Thank you.
You're welcome.
Is there any idea to upgrade Neon V4 in AArch64 in next releases? Because as I see, it's same engine which was in ARM V7 and so on.
The good thing is Neon unit in ARM V8 is mandatory now. So you don't have to, like on V7 where it was optional. But when it comes to how much work it takes to upgrade code written for V7 Neon to get it running on V8 Neon, I have to tell that I don't know. It's my last program I wrote was in previous millennium, the one which someone was using, and I'm just building software. So I didn't work on porting any Neon stuff, so cannot help. There are several libraries where you can check how they do Neon for V7 and Neon for V8. FFmpeg, for example, they have huge use of Neon code.
Yes, but for example, in Intel we have the situations that they had MMX and SSE and so on, and now they have AVX, and in case of ARM we have a Neon version 4, and is there any plan to increase the number of elements in vector and the size of elements and so?
Let me answer. Because the question was, on x86 you have MMX, SSE, AVX, etc., but you still have the same architecture. The change from x86 to x86-64 was just adding another 32-bit, right? And you have more or less the same CPU with with backward compatibility, and you only have to care which is this CPU has AVX or not. AArch64 was designed as new architecture. Several things were done in similar way as it was on ARM v7, but for some things were done in different ways. Registers got updated, register got separated from other, etc. So code which is using Neon, for example, usually needs to be rewritten partially at least. And when it comes to vector stuff, there is an extension, not yet available in any CPU. It's SVE, Scalable Vectors Extension, I think, which was done for high performance computing mostly. It will be, I hope that CPUs with them will be released in a year or two, because from tests on software models, it gives huge speed up in several calculations involving vectors. You have 512-bit registers for vector operations. Anyone? And like one of my colleagues wrote one day, we made ARM64 servers boring because at Red Hat we were pushing vendors to make sure that they will comply with standards. ARM company released 2 standards which defines what the hell ARM64 server is. One defines base hardware, which just has to be there. Second defines what kind of interfaces firmware has to provide. So on each ARM64 server, you have EFI to boot. You have hardware described by ACPI. And it's not the same ACPI as it was on x86, where everything was broken unless you were using Windows, right? ACPI is now open specification handled by UEFI forum, and most of changes in latest versions of ACPI were done because of ARM64 servers. So now, now the thing is that basically you take a rack, put few different ARM64 servers, You take a pen drive with installation of CentOS, for example. You plug into server number 1, and you run installation. You plug into server number 2, you run installation, just like on x86. You don't have to think which kernel image I have to use, which bootloader I have to use, will it work on my machine, etc. You take enterprise distro, you put it, it runs. I have one ARM V8 machine under my desk, and it was running Debian Jessie, Fedora, CentOS, RHEL Enterprise, without any issues. Yes? Any more questions? We have 5 minutes.
I have a very simple question about hardware. What are the reasons for vendors move from x64 architecture to ARM64?
Good question. What is the reason for vendors to move from x86, which everyone knows and loves, right, to ARM64? If you want to make hardware, now, if you want to make a server, for example, right, you go to Intel, you take CPU, you take a bridge, you take external network controller, another network controller, and you have a pile of chips you have to put on the board and put it into the rack. If you are a vendor company, you can discuss with someone who makes chips and have license for making ARM CPU, and they can make you one CPU, one chip, which has everything of this inside. Like, if you look at ThunderX from Cavium, you have one CPU. On server boards, it has the same radiator mountings as LGA 2011 for Xeons. You have over 100 of gigabit Ethernet, because you have several controllers. You have huge amount of storage controllers, a lot of cores, quad channel memory controllers, and everything is one chip. So you can squeeze more CPU power in less space. That's one thing. And the other thing, think about situation when you are AWS, Google, Facebook, or other company who has insane amount of hardware, right? Now, you buy x86 hardware, and you don't have any other choice, right? So the price is at some level. When you have a choice, will you go for x86, Power 8, ARM64? The market will have to react as well. I remember keynote from Facebook, something like 3 years ago at one of Linaro Connects. They told that basically at that time they had 4 types of servers at company. One was pure performance, other was pure IOPS, yet another one was purely storage, and they were at that time thinking of replacing some of them with different architectures, just to make sure that they will not have just Intel in their data center to get some kind of, the server company who makes the machines on Intel. We can buy some machines from you, but we want them 20% cheaper, right? Because we have few other companies who will sell us non-Intel hardware, which is also fine for us, and they provide it cheaper than you, but we like you because we bought 20 data centers from you, right?